So we're now going to take a look at some of the source code that's part of the ex1 case study. If we come over here and we take a look at the ex1 driver program, this is going to demonstrate those various kind of basic RxJava methods like just and map and blocking subscribe and so on. And of course, it's going to do it in the context of our async tester framework, but quite honestly, that's overkill because we're not doing anything asynchronously at this point. So you'll see that for this particular example, we're going to look at test fraction multiplication 1, and then later we'll come back and take a look at test fraction multiplication 2. So let me go ahead and jump down into that code. So here is test fraction multiplication 1, and that's going to test big fraction multiplication using a synchronous observable stream. So let's take a look and see how this works. First thing we're going to do is we're going to go ahead and build a string builder, and we use this for all the tests so that we can make sure that we print things out in a consistent way, even when the various processing is taking place in the background. Now, again, this particular test doesn't demonstrate that, but the later ones will. So the first thing we do is we apply the just factory method on observable, and that goes ahead and creates ourselves a stream of big fraction objects with the given numerators and denominators. So we're going to have big fraction where the numerator's 100, denominator's 3, numerator's 100, denominator's 4, numerator's 100, denominator's 2, and finally numerator's 100, denominator 1. And when I run the program for you, you'll see what the results are. The next thing we're going to do is we're going to go ahead and use the map method. And the map method is going to essentially multiply the big fraction by some constant. So you can see here, we're going to take each fraction that comes through each one of these big fractions, and we're going to say multiply that big fraction by this big constant. This is the big constant. You can see it's a big constant of big fraction constant. And that will then, of course, generate a bunch of multiplied big fractions. And it's also going to have the side effect of printing out what the reduced fraction, the constant is as a mixed string, and the fraction as a mixed string. And when I run the program, you'll see what that does. And then the third and final method here is a call to blocking subscribe. And blocking subscribe does a number of things. First and foremost, it's going to block. So we're not going to make any progress until the whole processing of that stream of big fractions is done being emitted and multiplied. And then secondly, as this runs, every time it succeeds, every time we get an on next event, that's going to be handled by the first parameter here, which is, you may recall, is a consumer. And what that consumer is going to do is it's going to go ahead and append the multiplied fraction to our string builder, and then it's going to go ahead and print a new line. So it's going to just keep appending it to the string builder. If an error were to occur, which it won't, but if the error were to occur, we would append the string error to the string buffer, string builder. And then finally, when we get the onComplete method, when the final call comes in from the publisher saying, I'm all done emitting everything, in that case, we're going to trigger the display of the string builder, and that'll go ahead and actually print it at that point to the standard output. Now, because blocking subscribe will block until all the processing is done, when we're all finished here, we're going to go ahead and return big fraction utils.s void m. And if you go ahead and take a look at what that is, that's just a completed completable. So all that means is it's just kind of a fancy way of saying, I'm done. It's a little bit like a completable future that's completed to be empty, if you will. So that's how we're just going to indicate there really was no need for the async tester framework to do anything, because by the time this method returns, we've finished with all the computations, and we're finished with all the computations, of course, because we used a blocking subscribe. So this is not the most exciting example of RxJava, but it's a good starting point, and you'll see that all the other variants we look at later build upon this and kind of relax some of the constraints with respect to asynchrony. So now we're back in the ex1 case study project. You can see we're in the ex1.java file, and we're about to take a look at the test fraction multiplication 2 method, which again uses synchronous observable streams in order to do big fraction multiplication. And it's going to take 2 different streams and merge them and then apply the multiplications to them. Let's pop down and take a look at this. This is test fraction multiplication 2. Once again, you can see we use a string builder to go ahead and put together the string that we're going to use to print the output when all is said and done. And I'll run the program here shortly to show you what it looks like. First thing we do, it looks very much like test fraction multiplication 1, we go ahead and get an observable that's just a bunch of big fractions with the same numerators and denominators in exactly the same order that we had done before. But here's where things get different. What we're going to do now is we're also going to make observable O2. So we have observable O1, which was just like we had before. Now we make observable O2. And the way we're going to do this is we're going to use the from callable factor method, which, if you recall, had those lazy semantics. And what's going to happen is every time this gets called, it's going to call the make big fraction factor method. And make big fraction, as you can see, goes ahead and makes us a big random fraction. And in this particular case, it's going to be a reduced fraction. And then we're going to apply the repeat operation. So we're going to make 4 random big fractions. So this is a way that we can use our from callable using the lazy operation that we talked about. And we're going to repeat it 4 times. So that's pretty cool. It's demonstrating how you can compose together the various operations defined on the RxJava observable. So when we're done with this, we're going to have O1 and O2, or when things get run. Remember, nothing actually starts to run until subscribe is hit. But at least conceptually, we can pretend as if this is what's going to happen when subscribe gets hit. So then what we're going to do is we're going to take O1 and we're going to merge it with O2. So we're going to flatten the current observable and the other observable into a single observable sequence without doing any transformations. Now, the results may or may not interleave. It's sort of timing specific as to whether they interleave. In this particular case, they're not going to interleave, but you could easily make them interleave by putting delays and so on, or having longer running computations that would cause them to interleave. So once we've gotten these two things merged, O1 and O2, then we're going to do what we did before. We're going to apply this map method to multiply each of these fractions by some big reduced fraction, which same constant we had before, and we're going to print out the results here. And then down below, we're going to go ahead and use blocking subscribe to essentially append all the results into the string builder. And then when we're all done and the onComplete event is signaled or triggered, then we're going to go ahead and display the string builder. And again, we return the empty mono to say we're done. So let's go ahead and run the program, and it should compile and run very quickly because it's all synchronous. And the processing that's taking place here is very short and to the point. So it's not doing some heavy duty computations. Although, honestly, some of the work you can see on the big fractions take a while. So here's what we get. Here's test fraction multiplication 1. You can see that this was the big reduced fraction. It turns out to be 4.5. And we multiply by that by 33 1/3, 25, 50, and 100, which match the numerators and denominators we made with our just factor method. And then after we do the multiplication, here's the results. As you can see with test fraction multiplication 2, the first 4 results are identical to what we had in test fraction multiplication 1. No surprise, because they're done with the same just method. But then down here, this is where we use that from callable in conjunction with our make big fraction factor method. And you can see that we make some pretty gigantic, honking, big fractions. I'm not even going to bother trying to scroll all the way to the right because they're so large. So of course, when we do those multiplications, then we're going to get much larger values. And again, I'm not going to try to show you all the values because they're very huge, but they demonstrate the fact that we can use these things and we can merge them together. Now, again, there was no interleaving in this case, although there could have been. So when you use merge with, it may or may not interleave, but it's possible to interleave. If you do not want interleaving, then you should go ahead and use concat with. In this case, we got the same behavior as concat with, but that's just because of the synchronous nature and the short processing nature of all the operations that we're doing in those streams.